All right, we're going to go ahead and do inverses. That's Algebra 2, Semester 1, Unit 441. And we're going to solve for inverses. So we're given f of x equals 5x. On our study guide, they actually have decent steps explaining how we do this. Is what they're going to say is you are going to replace your f of x with a y. So call this y. So now y equals 5x. And then what they're going to ask us to do is to change the x and the y. So all I'm going to do is, instead of writing y here, I'm going to write x equals 5y. And then I'm going to solve for y. Well, what's on the same side as y? 5, what's the 5 doing? It's multiplying. How do you get rid of multiplication? You divide. So I divide both sides by 5. So I have x over 5 equals y. I'm going to go ahead and flip this around. And then I'm going to put in inverse notation, which is going to be f negative 1 of x equals x divided by 5. This is the inverse. So these are inverses of each other. That's all it is. So if I come over here, let's do the next one. First step is I take this f of x and I make it a y. I'm then going to flip my x and my y. And then what I'll do is I'll simply solve for y. What's on the same side as y? Well, 10 and a 3. What's furthest away from y? We'll say the 3 is furthest away. What operation is subtracting? How do you get rid of subtracting? You add. So we're going to add both sides. Add 3 to both sides. So we have x plus 3 equals 10y. Again, solving for y. What's on the same side as y? 10. 10's on the same side as y. What operation is it doing? It's multiplying. How do you get rid of multiplication? You divide. So divide both sides by 10. Then we have x plus 3 divided by 10 equals y. Flip it around and change it into inverse notation. Boom. And now we have an inverse there. Excellent. We'll do one more. Alright, so first step, just like before, we're going to change this to f of x to y. And then rewrite everything else. I'm then going to flip my x and my y variables. I'm then going to solve for y. Well, what's on the same side as y? Well, now we have a 5, we have a 1, we have a 9. What's the furthest away from the y? And I guess it'd be operation-wise. So if I'm in this scenario, my furthest away I'm saying is the 9. Even though if you're talking about just like location, you could argue that the 9 is close to the y. But there's a division bar. It separates this. This 1 plus 1 is closer than the dividing by 9. So I'm going to go ahead and say that we got to get rid of the 9 first. So we're going to multiply both sides by 9. Excuse any excess noise in the background. We got Donkey Kong getting played. So we got 9x equals 5y plus 1. All right. We're solving for y. What's on the same side as y? We have a 5 and a 1. What's the furthest away from y? We'll say the 1. It's adding. How do you get rid of addition? We subtract. All right, so solving for y. It has a 5 with it. It's multiplying, so we divide it. All right, there we go. I'm going to go ahead and rearrange and rename. And that is my inverse. That's purple's a little bit more difficult to see. That is a f of inverse of x equals 9x minus 1 divided by 5. Excellent. Now, the last thing that we'll talk about is if we are given ordered pairs, and I'll just write down a couple quick ones. If I'm given ordered pairs, we'll say 1, 3, negative 2, negative 1, 7, negative 2. If I wanted to find the inverse, so these are all ordered pairs of my function f of x. If I wanted to go ahead and find the ordered pairs of the inverse, all I would have to do is flip the x and a y. It's that simple. That's all you gotta do. You just flip the ordered pairs. The x becomes the y becomes the x. Last thing, we'll talk about composition real quick. Might as well throw it all together. Is I'm going to take this middle example is 10x minus 3, and I'm going to use it. So we had the inverse here, and we have the function here, which was 10x minus 3, I believe. Scroll up. Yep. Excellent. So we're given these two functions. They're saying test to see if this is in fact an inverse. How do we do that? Well, it's going to be a composition. So what we will do is I'm going to take this equation and I'm going to plug it in for this x. So this is going to be 10 parentheses x plus 3 divided by 10. I just plugged in the other function in for the variable, in for the x. Everything else stays the same. And now we're going to go ahead and just simplify. I have 10 multiplying and I have 10 dividing. They cancel. So I have an x plus 3 minus 3. Well, plus 3 minus 3 is just going to be 0, and I'm left with an x. That's what we want. If we plug a function into another function and we we're left over with just x, that means it's an inverse. So we just prove that they're inverses. I'll go ahead and I'll do it the other way. I'm now going to take my equation x plus 3 divided by 10, but I'm going to go ahead and plug. Ooh, I gotta give myself a little more room. There we go. And we're going to take that 10x minus 3, and I just plugged it in for x. So I took this equation, I plugged it right in for that x. Now I'm here. I'm going to go ahead and drop the parentheses because I don't need it. These 3's minus 3 plus 3, they cancel. I'm running out of room here. I have 10x divided by 10. Will these 10's cancel? What do I have again? X. So that's good. That means I have inverses. That's all I'm looking for.